Hey everybody, today we're going to go ahead and look at solutions and solution formation and something called solubility. You should have some general ideas about what solutions are, but basically in this video lesson I'm just going to give you an idea of the differences between ionic compounds and molecular compounds, and we're going to look at how and why solutions form and give you a way to make that prediction. You can make a prediction on whether something will dissolve in a solvent based on the structure of the solute we're talking about. Okay, so you should know that there's two parts to a solution: the solute, which is what I'm going to use in here is salt, and my solvent, which is the water. Now the solvent is almost always the one that's in a larger amount. Okay, but we're going to see that the act of dissolving is actually a mutual thing between the solvent and the solute. We think of the solvent as being the doer of the dissolving, but really it's something that both of the solute and the solvent have in common. Now you should be familiar with the fact that table salt, which is what I have here, which is sodium chloride, NaCl. And if I take here, I'm going to do is I'm going to test something, which is called the conductivity test. Or you saw me use this in first semester, where I put a light bulb into the water and we could see if a light bulb lights up. Well, this is tap water, so we can see that it lights up just a little bit. You can see a little bit of light coming off of this light bulb. So what we're going to do is add some salt to this. So if I shake some salt into the water, we can see the concentration of the salt is going up. Okay, and then we can actually come over here and test the conductivity again. By plugging this in, we can see that the light bulb is now lighting up with a lot more energy. We get a brighter light bulb. And you remember I did this first semester, the light bulb lit up really, really bright. So if I keep adding salt, look what happens to the light. It gets brighter and brighter and brighter as my concentration goes up. This is referred to as an electrolyte. So we find is that we put ionic compounds into water and they dissolve, they are going to produce what's called an electrolyte. The solution is now considered an electrolyte. It allows an electrical energy to pass through. Because the connections here, they're not connected together, so the light bulb doesn't light up. When I put them in, the ions that are in the solution allow that to happen. Okay. Now let's see what happens if I remove the salt, or if I reset everything and I change this to sugar. Now you should know that sugar dissolves in water, so we'll go ahead and add some sugar to this. But something different happens when we put sugar in here. Okay, so if I put sugar, let's just go ahead and put a lot of sugar in here, let the concentration of sugar get really high. Or maybe not, but okay, so there's one way we can make it go higher is I can take out some of the water. So let's evaporate some of the water. You can see the concentration. Well, I guess it's not going to go up. It should, but anyway, well, I guess I'm out of sugar, no more is coming out. Point is, put this in here, no conductivity. Because the sugar is considered a non-electrolyte. The sugar is not giving us the ability to conduct an electric current. Okay, so let's see why. What's going on at the microscopic level with this? So let's go ahead and reset everything. Alright, so let's go ahead and put some sodium chloride in here. Remember, NaCl. When I put the NaCl in, what happens is these ions break up. So the little purple ones are the, or pink depending on your eye color here, what if you can determine the color there, are the sodium ions, and the larger green ones are the chloride ions. And notice that they're moving around and they're separating from each other. This is what allows the conduction of electric current, the fact that the ions break up. This is called dissociation. And when they break up into pieces and dissociate, these ions then allow the conduction of electric current. So let's go ahead and get that out of there. Let's go ahead and actually use some sugar. Okay, so if I put the sugar in here, watch what happens to the sugar molecules. The sugar molecules separate and spread out, but they are not dissociating and breaking apart. They're actually staying together in their sugar molecules. So what's happening is the water is surrounding and separating out the sugar molecule, but not the atoms in there. There's no ions in here, so therefore no conduction of electric current. We can actually go even deeper and look at this even a little bit more closely by looking at the water molecules really, really close up. So you got the oxygen is the red, hydrogen is the white ones. Okay, now watch what happens when I put sodium chloride into the water. Again, ions break up and they dissociate. Now the question is, why is this happening? What's going on that causes this to happen? Well, water has polarity to it. If you remember back in chapter, I honestly don't remember what the chapter was, but it was on bonding, or chapter on bonding. We talked about the fact that there's intermolecular forces between the substances. That actually wasn't in the bonding chapter. It was our chapter on, no, it was on bonding, I'm sorry. It was at the very end. We talked about the different types of intermolecular forces. Remember, water being polar has a negative side to the water molecule. So notice what happens here is a lot of the oxygens are lining up and are being attracted to that sodium ion. This is called hydration, when the water surrounds that ion. Now hopefully we can get a chloride ion in here again. Let's try that again. There's a reset over here. Let's go ahead and put the sodium chloride back in. And notice what happens here is that the hydrogen ions are attracting to, notice the white ones are all kind of attracting to the chloride ions. Again, attraction to the chloride. So we're getting the separation of ions by the fact that water is polarized, and so is the sodium ion. It has a positive charge, it's attracted to the water, and so is the chloride. Alright, so let's see what happens when we put the sugar into the water. We put sugar in the water, again we get the separation of the molecules, but notice they didn't break up. Okay, I'm going to show you in better detail. It's a little hard to see here what's going on because you can't really see the structure of this. But again, a separation of the sugar molecules is happening. The water is surrounding the whole sugar molecule and separating it out. Okay, so that should give you some idea at least as to what's going on at the solution level. Let me show you one more thing here actually. Let's take a look at what happens if I put calcium chloride in water. Here's the formula for calcium chloride, CaCl2. When I put that in here, watch what happens to the concentration of the ions. I get twice as many ions in solution than I do the chloride ions. Okay, I'm sorry, the calcium ions. So I get twice as many chloride ions as I do calcium ions because in the compound I have twice as many here. So therefore I'm going to have a higher concentration of chlorine ions than I will calcium ions. This is really important because when we think of ionic compounds dissolved in water, we don't think of them as a group. We think of them as the separate ions. And I'm going to talk about this in just a second, show you some calculations. We think of them as just separate ions. So let me go ahead and clear this out and put in another one. Let's say that I put in here, oh, I guess I don't have any other ones. I guess it was the only one. If I put in sodium nitrate. If I put in sodium nitrate, what do you think this is going to break up into? Okay, hopefully you remember that there's a polyatomic ion known as nitrate. So if I shake those ions into the solution, what I'm going to get is the nitrates break up and the sodium ions. And it's going to be an even ratio because I have one sodium to one nitrate, just like I would for sodium and chlorine. Okay, so if I pause this, you can see that the nitrates stay together because they're molecular. They're nitrogen and oxygens.